Hello everybody. In this video we're going to discuss not necessarily getting the equation of a parabola in standard form and graphing it, but necessarily having a parabola already graphed but trying to find its equation, okay? So we say finding the equation of a parabola in standard form. So what we're going to do is we're going to go ahead and start with, say, a picture here, okay? And we're going to go ahead and assume that actually the axis of this parabola is actually the x-axis itself, and why not go ahead and make its vertex at 0, 0 for the sake of simplicity, okay? But what we already know is that the vertex is at 0, 0, and what I'll also tell you is this. We'll make a new point here. We'll call it, say, negative 2, 1, 2, 3, 4, 5, 6, and we'll say, okay, why not? In my previous examples, I haven't been doing a lot that opens sideways, especially sideways and to the left. But if negative 2, 6 is on the graph, negative 2, negative 6 is also on this sucker. So it's just my lovely parabola right there. But let's go ahead and start by admitting a few things here, starting with the equation of a parabola in standard form. Always has a squared quantity on the left and a linear quantity on the right, we say, or vertex form. But it's also this. Since this parabola opens to the left, or it could have opened to the right, but since it opens to the left or horizontally or laterally, we're going to say that it's actually our y quantity that's being squared. So y minus its partner k squared on the left is equal to 4p times x minus h. Now what's going to make this possible is the fact that we already know the vertex here, which necessarily, I mean, if we think about this, are h and k respectively. And we also knew that this point, negative 2, 6, it lay on the graph here, or it is one of these locus of points here. They're equidistant from some directrix and some focus. Of course, we don't know the focus, nor do we know the directrix at this point. But the fact that we know that the vertex is at 0, 0 will allow us to go now and actually take those values and put them into this equation in standard form. So we've got this now. We say 4p, which of course we don't know p yet. We could infer into its nature, starting with the fact that, by the way, p, in this case, if you notice that since this opens to the left, we already know something about p, and I'll let you think about that one for a minute. But of course, we know that the vertex lies at an h value of 0 and a k value of 0. So we're going to clean this up just a little bit here, but what we can say now is this. This would be the quantity, y minus 0 squared would be y squared is equal to 4p. And now x minus 0 is actually just x. So a very, very clean equation. The only mystery at this point is what the heck p is. So in order to remedy this situation, what we're going to do is we're going to select any point from this locus of points here, because any point would really necessarily satisfy it. And since this is convenient, and I have two positive, or at least one positive value here, we'll go with this. But wherever we see x, we'll plug in negative 2, and wherever we see y, we'll plug in 6, because we know that this is a solution point for this equation. That is, it satisfies it, it verifies it, it makes it true. So what we'll do is we'll go ahead and substitute in by taking these out in the first place. So we say 4p, so this was our x value here, and our y value here, but we said y in this instance is 6, and x in this instance was negative 2. Now I want you to keep in mind our only ambition for doing this is to solve for p. Now if you've been thinking about this, you know what I mentioned, this graph opens to the left, what this does is it implies that our focus, wherever it is, you know, we'll call this point the focus, who knows, but it lies to the left of our vertex on this parabola, so it must be negative. So you start thinking about that already, but here we have this. We have 36 is equal to 4 times p times negative 2. I should have cleaned that up there, but we say 36 is equal to, now 4 times negative 2 is negative 8, and this is p. So let's go ahead and divide both sides by our negative 8 here. Negative 8, negative 8. Okay, so we say p, this implies that p is most definitely negative. And you know, 8 goes into 36, it doesn't divide it, but it goes in pretty nicely. So we say 36 negative 8ths, okay, but we could say that's necessarily 18 over 4. Of course, that is 9 over 2. Or if you just want to say 3 halves, or 3 and a half, excuse me, you can. I'm a little bit more partial to 9 halves. But what this allows us to do now is to go back up into our equation and insert that in for p. So now bringing on over here, we say, okay, so y squared is equal to 4. We'll substitute that value of 9 halves in here. and that was times x. So now we see that our 4 and our 2 react here. They have a common factor of 2. So this becomes 1, and this, a 2 goes into this twice. We say 2 times 9 over 1 times 1. Now we have this. We say y squared is equal to 18. X is the equation of our parabola. And just, to say a few more things about this, we said, pardon me. This was negative, this quantity negative, this p-value was negative. But we'd say, okay, so this would, 3.5. Man, I'm making mistakes all over the place. This is 4.5, please forgive me, and negative. So life's about second chances these days anyways, I hope. But that our focus would lie 4 units to the left of 0, 0. So we could actually call this point, if I had drawn this accurately, negative 4.5, comma 0. And we'd know that the directrix lies 4.5 units then to the right on this line. Y equals, x equals 4.5. So anyways, remember the ambition here was to find the equation. We were able to do so. But just to check this, what you could do is you could kind of backtrack your steps and see that this actually is this parabola. So enjoy.